All right, so we're gonna go over really quickly this challenge problem, and then you'll be able to use this to go back and look at the two triangular prism problems from page 59 for yesterday. If you didn't get a chance to attempt these yet, or you got to them and weren't really sure where to start, check out this video here, and then afterwards, hopefully you'll have a better idea on how to solve those problems with triangular prisms. So first thing I want to talk about is thinking back to what we know about the relationship of a triangle to a rectangle. When we would find the area of a triangle, we would take the length and multiply it times the height, just like we would in a rectangle. But then what we found was that the triangles are half of the area of a rectangle. So when we are looking at the volume of a triangular prism, such as in this challenge problem, if we were to imagine this triangular prism as a rectangular prism, it would have that same relationship. So we would find the area of this triangular prism by finding the length, which is 3 centimeters, times the width, which is, or height, times 5, and then times 6, which is the width. And what we would get there is 90 centimeters cubed, but that would be if this were a rectangular prism, and it's not. If we were to have two of these triangular prisms placed on top of each other, that would make that rectangular prism. So we know that a triangular prism, or we could visualize or see that this triangular prism is going to be half of the rectangular prism. So we would divide this by 2 to find out that it was 45 centimeters cubed. Now, I know that this does not ask us to find the surface area of this shape. However, on the page 59, we are asked to find the surface area of two shapes that are very similar. So when finding the surface area, that's when we're trying to find out all the pieces of the puzzle that go together on the outside, all those shapes, those two-dimensional flat shapes on the outside that create this three-dimensional figure. So one of the ways we talk about visualizing or seeing this shape is if we open it up and make it flat into a net. So if we're picturing this triangular prism right here as a flat, we know that there's this rectangular slanted side, and then there's the bottom side, which is going to be another rectangle, and then there's that back side, that back where 5 centimeters is, this kind of back view here, which is another rectangle. Coming off of that, we have a triangle on one side and an identical triangle on the back. So now that we have this shape flattened down, we can go through and put these dimensions in to find the pieces of the puzzle to find the surface area. So this base right here, 3 centimeters, is this same measurement right here, 3 centimeters on the base of the triangle and on the base of this rectangle and the base of that triangle. This 5 centimeters is the height of that triangle. It is also the height of the back rectangle. And it's the height of this triangle as well. And then the 6 centimeters is this width across, which goes across all of those rectangles. So then the final length that we're going to need is this side piece, this kind of angled piece right here. And on page 59, you're given that. For this problem, we didn't need it for the volume, so I'm just going to make up a number. I'm just going to say that this is also 5 centimeters. So that is now the measurement of the this flat rectangle coming up here as well. Now that we've got all of these measurements for each of these pieces, we would solve this just like we would a rectangular surface area, but now we just have these two triangles to think about as well. So again, thinking about the relationship between these triangles and a rectangle, if I were to find the area of the rectangle first, I can then use that to find the area of the triangle. And if this triangle is 7.5 centimeters squared, this identical triangle on the back side is also 7.5 centimeters squared, Then the same thing, we would solve for these areas of all the rectangles just as we have all week, knowing that this one would be a 5 by 6, this is a 3 by 6, and this is also a 5 by 6. We put all those measurements together, add them all up to find the total surface area of this triangular prism. So again, this is just an example. Now, when you're working on page 59, I realize that the numbers seem to be larger because you're working with 30s and 40s and numbers that are in the tens. However, break those numbers down into single digit numbers to help you solve that problem. So like if we're on the next page, you know 30 times 40, breaking that down into 3 times 4 first, and then you know 30 times 40 is 1,200. So use what you know about place value to help make those numbers smaller and more manageable as you're working with them. And good luck. Let me know if you need any more help or have any more questions. And I look forward to seeing a few resubmissions today if you want to go back and change your work.